Welcome to the webinar on life cycle assessment. Christina Lemaitre invited you for this webinar, and actually I was quite overwhelmed by the interest that you around the world have shown when she just wrote this little invitation that we are happy to let you know a little bit about our experiences on the journey towards truly better buildings, and on our journey by when we decided 10 years ago that life cycle assessment should be an integral part of a sustainable building assessment. I hope you find interesting what I have prepared for you today, and I'm really happy to share our experience. My name, if you don't know me, I know some of you. If you don't know me yet, my name is Anna, and I'm an environmental engineer with quite some experience in life cycle assessment methodology and application, of course, actually since 1999. I calculated dozens of LCAs myself for all different types of systems like computers and monitors, wastewater treatment plants, biofuel generation, building products, full buildings, a lot of buildings, and districts as well. I'm sitting here in sunny Stuttgart, it's 2 p.m. Stuttgart is home of DGNB, and I'll lead you through the next 60 minutes, and the presentation I have prepared, I hope it won't take all the full hour, because I really like to use the time to discuss your questions you might have. Actually, I would like to lead you through the 4 main phases of our story with full building life cycle assessment. So our phase 1, we wanted to know more. It was important to get data. Our phase 2 was now we want to calculate full building LCAs, but how can we do that pragmatically? Our phase 3 was then, okay, now we got results, how can we interpret them? And last but not least, where we are today, we have some lessons learned, and we have some challenges ahead, and I would like to give you a short insight into what we are doing or what we're planning to do in our version 17 with LCA. So phase number 1, you might also be in a position you want to know more. Like our first question 10 years ago was, is this building, not exactly this building because it wasn't built 10 years ago, but is this building an environmental friendly building, and did the team consider more aspects than just the energy performance? And when we raised those questions, we knew that with current methodology or current calculations, metrics, we weren't able to answer those questions. And therefore, in 2007, we started with defining the DGNB scheme principles, which are that we have to get the entire picture of the built environment or the object under assessment, and therefore we only award projects with the best full life cycle performance. Secondly, we want to encourage good results in all sustainability dimensions and not just in selected dimensions. So the holistic view is also one of our scheme principles. And the third principle is that we always strive to find metrics and solutions where we work performance-based and not on checklist features assessments. Just a quick overview how we managed to work with these principles. On the one hand side, we defined our so-called quality groups, the environmental, economic, and social, cultural, and functional quality as the typical sustainability dimensions. We also have a group which is the technical quality, which contains quite some technical aspects of buildings, and we have the process quality where we have indicators and criteria which lead a project team towards a real sustainable building. And last but not least, we assess the site quality. And when it comes to performance-based, what we have learned is that simple checkboxes very often, if only a feature is being seen as green or as sustainable, it very often misleads. And if the context where the building or the object is located or what can be done, then these checkboxes really don't help. And secondly, they hinder, from our perspective, innovation. And therefore we said we really want to encourage design for sustainability. And I know it's quite difficult, but we really work on getting the performance perspective into our criteria, where it's more important to look at the input and output and evaluate those metrics and not on how it was done. The third aspect, the full life cycle, is not just the life cycle of the planning. We know it's very important to start in the design phase of the building to bring it into the realization phase when it comes to new buildings, and there we have our certificate, for example, when the building is ready to be used. But it's also, of course, important to look at the operation and refurbishment and conversion later on. But when it comes to life cycle aspects, for example, we have also seen that it is very important to, here in this case, when it comes to energy performance, for example, that regulatory politics are very good in supporting long-term goals. You can see these pie charts. The very left pie chart is 1984 regulation of buildings, of residential buildings, how the energy performance looks like. So a lot of power was used for heating. A lot of power was also used for the user, and then regulation started to work on getting this heating and hot water generation and the auxiliary power down, and this really worked. The pie gets smaller and smaller, but what is getting now much more into the focus when it comes to energy and also other environmental aspects is, of course, the embodied impacts in the materials and also the power that is used for the user, and that is in Germany not regulated at all. So this life cycle perspective in this case showed us the development that we really have to take a look at, here in this case, the embodied impacts, for example. And therefore we had the ideas in 2007 that we want to understand the environmental impacts and the effects of a building's life cycle, and that life cycle assessment methodology should be a standard tool for design teams. That was what we wanted to achieve. And that secondly, if anybody says this is an environmental friendly building, this claim should be based on a life cycle perspective or on a full life cycle assessment results. So why is it important to consider the full life cycle? On the one hand side, we know that the focus on energy consumption only during the operation becomes misleading, and I think this is the case in Europe and elsewhere, that it is covered by legal requirements anyways, and we as DGNB we want to go beyond. Secondly, we know that widening the scopes helps making better decisions for truly better buildings. So when I start thinking of where does it come from, what is happening with it, you really can say that you make better decisions for the future and for other generations. Thirdly, with the life cycle perspective, you can calculate the environmental return on invest. So how much, what do I get from my invest from an environmental perspective? So insulation or whatever feature you include, you can see directly by using LCA methodology what comes out for actually throughout the lifetime of the building. And last but not least, of course, as an environmental engineer, it is always important to prevent the shift of burdens to other life cycle stages. So if I do something in the production phase and I don't think about the end of life, then nothing is gained. But then we had the question, how can we start? So what's first, the chicken or the chicken egg? And we knew as a phase one we need to get data to start. We had in Germany a so-called generic start database. I think it was just 300 data sets that were included. It was developed with industry involvement and supported by the German federal government, and at that time it was in line with the EPD methodology as far as it was possible in 2007. And the start allowed us actually to go further, and the database that was further developed had a big increase of interest, and more data sets came into that database. In 2009 there were already 650 data sets for all different product types, as you can see here, and this allowed us to calculate full LCAs, although of course 650 data sets is not representing the whole bunch of building products that are available on the market. But anyways, it was a very good start and allowed us to ask for full building LCAs. If you're interested in looking at the latest version of the database, it's publicly available. It's called ökobaudat.de. You can find it when you search on Google. It's more than 1,000 products now included, and it is, by the way, now EN 15804 compliant. So the results look a little bit dull, but when you know the methodology that is used in Europe since 2012, the database, the 2013 version, followed exactly this EN 15804 methodology, the indicators, the modules, and everything that is required by the European standard. And then, of course, it was also important for the manufacturers to show that they are producing what they are producing, like EPDs, that they can find it wherever they put it. And we also have our DGNB Navigator database, which includes EPD data sets of various building products. So phase one, getting the data. We started in 2008 with the first generic LCA database, which was based on a consistent methodology, and this allowed us to integrate full building LCA into our DGNB scheme. Since 2009, this database is called ökobaudat. It is a result of the collaboration of LCA experts, database providers, EPD providers, building ministry, and industry. in 2011, DGNB learned from this experience, and we developed and released further START databases, European average, Brazil, China. I'll show you later some content of that. And since 2012, the European standard for EPDs or LCA data, the EN 15804, was released, and this was also a big boost in Germany to do EPDs and provide EPD or LCA data in a very consistent and clear methodological way. Very briefly, what I just said on the START databases, we as DGNB have also an international scheme that can be used, and we know that the German database is not the right tool for many applications, and therefore we have developed the ESUCO database, a European Sustainable Construction Database with about 500 different materials and country-specific data for energy production, and it is available for all DGNB auditors. If you want to know more, I'm happy to provide you more information. And the same we did for Brazil and China, and I think also for Eastern Europe average as well. So now we had the data, we were able to say, now we want to calculate the full building LCA, but how can this be done pragmatically in an environment where planners and designers are already very, very specialized where we all said it really brings so much value to know more about the buildings or the building products that you're intending to use. So how can we do this? So for those who don't know LCA at all, I think this slide is the easiest way to explain LCA. There's first of all, you define the phases of the life cycle that you're intending to consider. So like the production phase and the use phase and the end of life. Then you have different life cycle stages. You can separate these phases into more specific stages, or as it is now done in the standards in modules, life cycle modules. And then actually somebody, brave people, sit down and look at all the inputs, the resources that are needed for each and every product step for this life cycle, and all the emissions and waste generations, and it is a huge amount of work. But the good news then is you have hundreds and thousands of entries for such a production chain, but then the impact assessment comes and uses so-called characterization factors for indicators, and then calculates so-called indicator results, environmental indicator results that allow to work with all the thousands and thousands of entries of single emissions. So at the end you have indicator results, and this is what people can use to optimize their products, their production, or to choose or to make claims about the environmental effects. As DGNB, we said, okay, we have to write down a standard how to do this calculation now for buildings. And in 2008, we released our first version, which included already LCA calculation as very important criteria within the scheme. And these standards, the standard how to calculate a building LCA, I think today it contains maybe 30 or 40 pages of description on how to do this exactly. As I said, in 2008, the first DGNB scheme was released, and the first DGNB scheme already included LCA calculations. And we had to have these criteria which defined the rules to compare the LCA results at the end. We have selected the environmental indicators: global warming potential, eutrophication potential, acidification potential, photochemical ozone creation potential, and ozone depletion potential. That's what behind these abbreviations: EPAP, POCP, and ODP. So it's 5 emission-related indicators we have chosen, and 3 resource-related indicators: primary energy fossil, primary energy the total, and the share of primary energy renewables. And after we have selected those indicators, we define the system boundaries that needs to be studied to have comparable results. Everybody can calculate as much as he or she wants to, but if you want to have comparable results, you need to define a common understanding of the system boundaries. So we said the production of the construction materials needs to be inside, scenarios for replacements, scenarios for end of life, and scenario for the operational energy use. And we have taken out some modules out of the system boundaries. I'll show you later, for pragmatic reasons, because else it might have been the full picture of everything, but it won't help to get better buildings. Especially for the selection of the construction materials, we have offered from the very beginning 2 options. Either you could do the detailed method, which includes everything that is in the building, or the simplified method, which has a predefined content of building elements that should be looked at. And then the building lifecycle assessment is nothing else but simple calculation of, actually you're adding the construction and the replacement and the end of life and the operation. We have defined the use, the lifetime under consideration of 50 years for typical buildings. For industrial buildings, we have chosen 20 years. Then you multiply it with the LCA data, e.g. the reference database, Ökobaudat, or with EPDs if you already know which product you built in and the EPD is available, and then you get out the environmental building profile, so the full building LCA result for the selected indicators. And the lifecycle modules that we have chosen, and now the EN 15978, it's a European standard which explains how to calculate building LCA, how to communicate on the calculation of building LCAs. You can see it here. It's these life cycle phases again, and the so-called modules, and the ones with the X, those are the modules we are currently and from the very beginning have taken into account. So we look at the cradle to gate, production of raw materials, transport and production. We don't ask for the transport to the construction site, transportation to construction site. We don't ask for the construction process itself. We then ask for actually the exchange of the of those modules, of those building elements which have replacement cycles below the lifetime, the selected lifetime of the building. I'll tell you a bit later on that. We look at the energy consumption during operation, since the 2015 version, also the water consumption. But then when it comes to the end of life, we look at the waste processing processes, but not the transport or the demolition aspects at the disposal. And we have included Module D, famous Module D, the potential for reuse and recycling, so the benefits outside the system boundaries. So pragmatically, we said we want to consider in the building LCA only this information that architects or the design teams can deliver and that can be influenced by the team as well. So we knew, for example, transportation, of course there is a way of influencing it, but to get the information which truck type was used, how many kilometers it drove, was a bit too much, especially in the beginning. And some aspects, for some aspects we said, for example, the transport to the end of life, that's so much in future, and we don't know exactly how this will look like. We took that out, and if everybody takes it out, the mistake at least is the same for everybody. The building elements that are to be assessed by when using the simplified calculation method, and I can assure you that nearly everybody is using the simplified method. So there are some brave people who use the detailed methodology, but this is really work when you really want to get everything into the LCA, and the tools that are currently used or on the market are sometimes not, it would be too much effort, and so everybody uses the simplified calculation method, which is okay, because it really is helps people getting away from the pure energy perspective into the embodied impacts perspective as well. So the buildings elements that are to be assessed can be seen here. You might ask yourself, so what about the building technology? What about the cables and so on and so forth? We have said that cables and building technology is out of scope except the central heating and cooling generation units, and we have put a factor 1.1 that is to be used when using the simplified method on the entire results. We have increased this factor now to 1.2 because we have evaluated studies that show that the building technology is around 20% of the total environmental impacts of a full building LCA. So we have increased that factor. This can be seen. People can say, well, this is critical, you're neglecting, but on the other hand, if we would ask for too much information, people wouldn't do LCA or wouldn't follow this idea at all. So we use this factor that comes on top. Then, sorry for this, that's German, but for the life or the replacement cycles, we have in the first stage we have worked with a very limited list, but at least a common list of defined lifetimes of typical building products. This list was released by the German Federal Ministry, and we are very happy that this list or the work on typical lifetimes, that there was some research projects going on, and there's now a quite good and extensive list on typical lifetimes, and these lifetimes are to be should be used in the LCA calculations if a manufacturer has proof that in his case the lifetimes are much longer, much shorter. However, they can implement as well the specific values. There's also a standard, an ISO standard that tells exactly how to get to those figures. But usually people use this list, and yeah, since it's only in German, but if you have some translators, I can give you the hint where you can find that. Then for the operational energy demand, sorry for this, we knew that we need to calculate, or we need to use calculated results for the new buildings. So we have the real building where we have the energy regulation that says how the energy calculation of a building should be done, and we use the results of the calculation, so the final energy we take from that calculation, and we combine it then with the emission factors out of the Ökobaudat, for example, of specific heating or electricity data sets. And here you can see in our legislation, the calculation of a reference building is already required, and the results of the reference building is also used in the calculation of the reference value. I come to that later, but actually this is really helpful in in getting very object-specific references. Then the famous modules C and D, the end of life of the building. We said the end of life needs to be calculated. A scenario for this end of life needs to be calculated, although of course we know it might be in a very, very long time that this end of life might occur, but of course it needs to be considered, and we have decided as well to take the benefits and loads beyond the system boundaries, how it's called, into the calculation, into the system boundaries as well. And we have defined scenarios for different types of building products such as metals, plastics, wood, mineral waste, and others. And the technology that we have taken in the data sets, or that needs to be taken in the data sets, have to be current typical disposal or recycling routes. So what is happening today is sort of part of the scenario for the future. So there's no adaptation or looking into the future, how a future recycling route or future disposal might look like. It is today's situation sort of transferred into the future. The environmental parameters, as they are called in EN 5978, that we have chosen from the very beginning. I already named them. Here you have the exact names. We have chosen to use ADP elements since our latest version in 2015, since only then we had the fitting database for that. So in 2013, the EN 15804 compliant database was available, and in 2015, when we released the next version, we said, okay, we want to have the calculation results of ADP elements, because this is an indicator that we saw missing in as a resource-related indicator, and the freshwater use of net freshwater indicator is also a new indicator that we want to see now as results in the building LCA calculation. We are not using other indicators yet because we have the freedom actually to select those that we find most appropriate to drive forward our targets. This doesn't mean, for example, that we're not interested in recycling or disposal, but we have a different way and different criteria to look at that that are a little bit different from what the standard asks as information of a building. And actually the provision then at the end of, so we get hundreds and hundreds of LCA calculations from the building spec, and we have decided from the very beginning that this should be done in a very strict way, a table that is defined by DGNB, so we can take out the results and build our own benchmark library. So again, very pragmatic. We have said we want the results in this structure because then we can work with this further. So the phase 3 was then, now we got all the results, what can we do with this and what does it mean? Maybe just a little bit of an insight into DGNB, how we are weighting and evaluating. So sort of the highest level is you get a certificate in a platinum, gold, silver or bronze color. This flower, as we call it, shows you the performance of each and every indicator, and the calculation of the levels of the awards is done by a total performance index. So we are working with percentages. The total percentage of all criteria that are relevant to be regarded gives you the result of the award. So from 80% you get platinum, from 65 to 80 it's gold, from 50 to 65 it's silver. Then we have a minimum performance index for all our so-called quality groups. So this makes sure that a platinum building has at least 65% in all quality groups. So it's a holistically balanced sustainability performance and not just one that is very, very good in one quality and is very bad in others. So this is a very important actually method to make sure that the buildings that we are awarding are truly sustainable. We have for office buildings 40 sustainability criteria. The weighting is done over the sort of the so-called quality groups. As you have seen before. So here is the excerpt of the environmental quality group for offices, version 2014 in this case. And then we have so-called relevance factors, which give the relevance of the criteria and calculates then helps calculating the share of the total score of the criteria in the entire scheme. And you can see here N1.1 and N2.1 are our two LCA criteria, and they make up together more than 13% of the entire mark. So for LCA, when it comes to the how good are the results or how bad are the results, we said we will provide benchmarks, and we did this from the very beginning. But just to make you to give you an insight into this benchmark generation, we call this the benchmark. They are based on a reference value. The reference value consists of it's a total life cycle benchmark, construction plus use. For construction, we have a fixed benchmark for all environmental indicators plus primary energy. And this is in the example of global warming potential, it's 9.4 kilogram CO2 equivalents per square meter and year. So this is the amount or this is our benchmark for the construction, so everything construction, replacement and end of life. And for the operation, we have as I showed you before, we use the reference value of the energy calculation that has to be done anyways. This has to be multiplied for electricity and heat with emission factors in this case, and gives you then the result of the operational global warming potential of the reference building, the sum of those 9.4 plus the operation is then the total life cycle reference value, and this is exactly the same for all the other indicators as well. The reference value itself is worth half of the points. It's good practice, it's okay. Then we have a limit value, and we have a target value, which gives you 10 points out of 100 out of 100. And then very important, what is the limit and the target? We said the target value, which is here, is 30% better than the reference, and this you can see throughout the entire throughout most of the values. But for the limit value, we have evaluated, done some statistical analysis, and we have seen, for example, that the spread of the results is quite different over the indicators, and therefore sort of the limit value is differing between the different impact indicators. Then we needed to weight the factors against each others. So how important is global, I'm sorry, this is a really bad picture here, how important is global warming potential compared to ODP, POCP, AP, and EP? Here you see the current weighting factors, and for primary energy, non-renewable, primary energy total, and primary energy or the share of primary energy renewable, we have chosen those weighting factors to calculate at the end the results. So when it comes to the benchmarks, the version 2008 was based or derived from a research study on around 50 buildings. And this 2008 baseline was then improved by using our own statistical results. So our own benchmark library grew and grew and grew, and now we have a good baseline for the reference value derived from certification or certified projects. For the operational energy, we have improved our emission or the primary energy factors that are used in the calculation of the reference value according to current heating and power grid mix status. So this is also always under development, so the better the German electricity mix becomes, of course, the better or the lower than the emission factor for electricity in the reference value calculation becomes. For the version 2015, we added new environmental indicators, ADP elements and freshwater, but for those we don't have benchmarks yet. We only ask for the calculation of the results to build up an own new benchmark library for those two indicators. If anybody of you has information on how important or on where the what the freshwater sort of the freshwater use of a full building is, I'm happy to get the information of ADP elements. I haven't found any. So last phase, that's where we are now today. What are our lessons learned? When I look back now 10 years of DGNB system and DGNB as an association, and a few and many years of LCA calculation, one of the lessons learned is that having, for example, consistent LCA tools on the market took actually much longer than we thought in the beginning. When we released the first DGNB scheme in 2008, my maybe naive thinking was, well, in 2-3 years we will have a lot of LCA tools and they can be used, so we will have a selection, and LCA calculation will be easy, so people can concentrate on the results. Today we have actually around about 5 LCA tools available that can be used for DGNB calculation, and of course various dozens of Excel or Access solutions, but that we are also accepting in certification. This is one of the tools that is used quite frequently. It's an online tool, so if you're interested in getting an insight, I think there's also an English version available. You can, yeah, the providers, I think, I'm more than happy to guide you through that. For districts, that's maybe a different story, but anyways, for districts we also have a DGNB scheme, which is a little bit different, but for districts we said that we will develop our own master tool, as we call it. It's an Excel-based LCA calculation tool that can be used very easily and that contains all the data that should be used to calculate the LCA of a district. The second actually lesson that we learned is that there are really quite some barriers to use LCA in early planning stages. When you think of when is such a perspective, environmental perspective over the whole lifetime of highest value, everybody agrees that it is in early planning stages, but we don't see a lot of projects that really use LCA in these stages. It's very often that only at the end, shortly before handing in the information to DGNB, the LCA of the existing building is then calculated, but it's not really used for environmental or to create truly better buildings. So we know it is a question of cost and effort and the knowledge and the tools. So what we have done or decided just now is that in our version 17 we give, again, of course, incentives to score below the limit or above the reference values, as I explained before. Those are the main points, but additionally we want to give incentives to so points to use if LCA was used in early planning stages, with different experts included. We also give points if user-dependent energy demand is incorporated into LCA, because we know this is the next big thing. Regulation moves forward, but user energy, for example, is not under consideration at all, and growing comfort requirements make this even more difficult, the situation. And then we give incentives also to if simulations are used when calculating the LCA, because we are convinced that the simulations as tools provide much better insight into the real performance of the building. They allow to calculate energy storage systems properly. They allow to calculate the interactions with the user properly, and therefore we definitely want to push this forward because it's very important to look at further aspects. Then we give boni for carbon neutral or carbon positive building operation, carbon positive operation of the user equipment, and for, if we will ever find it, also quite some a bonus for carbon positive embodied emissions. That's a sneak preview into our version 17. And then the last challenge that we have up front is that yesterday I just gave an 8-hour teaching course here in Stuttgart to architects and energy planners on LCA, and it is said that, okay, it's yet another specialist discipline. We know today it looks like only specialists can do that, but this is also a question of the availability of tools, and I'm very confident that the tool situation will change in near future, and then it becomes much easier, and current can become a standard practice in planning. If this little course on LCA that I gave you gives you an idea of how LCA can be done. I would be happy. I'm now at the end of my presentation. I would be happy to hear a lot of yes, I want to become an LCA specialist myself, or I want to teach others, or I want to incorporate that into our schemes, or however you work on improving the sustainability of the built environment in your country. And now we have, again, still 10 minutes to discuss and answer all the questions you have. I thank you very much for your for your time, and I know it is not always everywhere 2 p.m. in the afternoon. I really appreciate that there's so many people, 26 participants in this call. So thank you. You can either type in your questions into the chat function, or I don't know how it works. I just need to get this done. Maybe you can raise your arm, maybe, and then I can unmute you as well. So there is questions. So if the chat function is used, oh gosh, me and the technique. Yes, I can hear you, can hear me. Oh, okay, I see now. Okay, there's questions. So the slides will be a copy of the slides. Yes, we will, I hope I did everything correctly. I recorded the session and the slides. I'm happy to share that. How does the LCA contemplate good outputs like energy produced in the building over its consumption needs? Paula, I don't exactly get this question. Oh gosh. The eco-design or the materials that will be usable after the building. Paula, I really am, I have trouble in, and maybe Paula, I can unmute you if you're still on the line. Yep. Paula, if you would like.
Anna.
Hello.
Hello. Yeah, my first question is about the outputs. You talk about the waste outputs or the emissions outputs, but there are other things that go out from the building that are very good, like the excedent of the energy, for example, the renewable energy that is produced and is not consumed in the building, because the building don't need so much energy. And my question is how the LCA contemplates that kind of output.
Okay, so the way we are doing is that the additional energy that is generated and given, for example, to the grid can be, oh gosh, you can, oh gosh, what's the terminology? You can offset, actually. It's a oh god, I just missed the word. I'm really sorry. So you use the amount of energy and you replace the grid energy, the same amount of grid energy. So you can offset, for example, the emissions that you are replacing. So I know there's a better terminology. I'm sorry, I missed the word. And in our version for offices, we have limited that for the first 20 years. And after 20 years, it is sort of cut off because we have seen some buildings where the effect was a bit too high, but in our next version we said that we are going to change it because also technology is changing. So the energy you're generating and you're giving to the grid replaces grid, and therefore you have this replacement.
Okay.
And if heat would be the same, then yeah.
Okay, thank you.
You had another question maybe, Paula, that I didn't...
Yeah, the other question is very similar, but with the materials and the eco-design. It's about the circular economy. Now you can build a building thinking in the future and how the materials can be used after the life cycle. So my question is too, if the LCA contemplates that aspect.
Okay, so the way we are doing is that we do this based on the material, recyclability of the material, but we also have a recycling criteria, which is much more specific in that. But in LCA, the materials that can be reused, for example, we actually we use current end-of-life standard procedures. So if, for example, you have metal in your building and this is used then in another building, then of course this is part of this recycling potential data set that is to be used. So all the materials that are used anyways, they are part, or the benefits you get from this recycling or reusing them, which is sort of a typical way. This is done in the module D calculation. But we have an additional recycling criteria which gives much more specific and more credits actually for following the circular economy.
Okay, thank you.
You're welcome. Then I just want to go through the other some of the questions. Rafael, you asked 20 years for industrial buildings. Yes, we have decided for 20 years for industrial buildings and 50 years for all the other buildings. Then another question, how did you turn? The weighting factors, Nicole is asking for the weighting factors. Yeah, the weighting factors was a big discussion. We did this together actually with the federal ministry. The weighting factors, sort of the indicators against each others. We did it with the federal ministry. We have developed the scheme together, and the question of the weighting has been done on a big round table. I would say quite okay evaluation of how we give these factors. Yeah, that was discussed widely. We are just about to adapt these weighting factors because we have some experience and we looked into the data sets and databases, and there will be some changes in the next version. But I'm happy to talk about that more in 4 weeks when we release our 2017 version. How do I become a building LCA specialist? We give courses and I don't know, so I'm happy to teach, or if there's more interest in doing this, we have an international academy as well, and part of LCA, how to calculate LCA is part of our academy, for example. Audrey, you asked why we're not including the transport module. This is we have done some calculation on what if transport was included, and transportation to construction site is important. There's no discussion around. But the effort to get the information, if you want to do it correctly, is quite high for the auditors or the ones who has to calculate. If you want to do it simplified, then it might be nice to have it inside. But there is actually, we don't see a lot of value of having it inside because the sphere of influence is much lower than, for example, the selection of a material. So you're not selecting your supplier according to the transport distances. Maybe in a different country we would do it differently, but in Germany we have some average transportation distances of 300 to 400 kilometers, and therefore it would be a huge work to get the information which transport vehicle has been used, what distances has been used, and so on. So it was very pragmatic, but evaluations show it's about 5 to 10% higher results. Then, yeah, Pat, we're happy to support you. Are you considering banked? Are you considering specific LCAs in the future? I don't know if I get this question specific. Maybe banked. I unmute you if I get you. Oh gosh, banked. If you want to talk, you can talk now.
Okay. Hello, Anna.
Hello.
Do you hear me? Hi. My question is about product-specific LCAs. We have a big discussion in Sweden about that because we think that having generic LCAs is probably not the solution for the future, because what we want is to have, for instance, cement companies competing to make the better cement, or the better steel companies making better steel, and so forth. So if you have to declare your own specific product, it will drive the market for good materials. That's why I'm asking.
Mm-hmm. So yes, actually we have a lot of discussions, and we not only discuss product-specific LCAs. I'm just no, I don't have the slide here. Sorry for it looks very confusing what I'm doing here, but anyways, no, I don't have the slide. We have a lot of discussion. We don't have only product-specific data, but we sometimes have EPDs, which are like site-specific data, or very production site-specific data. And actually, we said that we allow or we want to strive for the more specific the data, or the closer actually the picture of the LCA model fits together with the final building, the better. So the rule is actually you should be as specific as possible. If you're not specific, you can use the generic data. So we said we want to have it as specific as possible, and therefore if an auditor can prove that exactly this product from this manufacturer, even from that site, is in his building, then it is sort of allowed. It's not just allowed, it's actually the way we want to see it in the future as well.
So are your generic data worse, or I mean not average, but worse than average, because that's how to drive the market?
Yeah, so with the federal ministry, in my former position, I was responsible for the Ökobauer database development, and in the 2013 version, we have offered a methodology for the generic data. I worked for ThinkStep or PE International at that time. We have offered a methodology to have penalties on the data, on the results, and we have chosen a way that characterizes the data sets. If you're able to read German, I'm happy to send you the link to this methodology, because I'm really very convinced that this is, again, a very pragmatic but feasible way to give sort of this, to say that not all generic data is generic data. So it is in some cases when you know where the data is coming from, and that it's not average, and that it's really, you're happy that you have data at all, then a high penalty of 30% is chosen on the indicator results. Then a second class would be a 20% penalty, and sort of generic data with even still a good quality, but still becomes a 10% sort of malus on the indicator results. I'm happy to share this document, but it's in German. But yeah, we have done a lot of, or in the past I've done a lot of association LCA studies as well, and the average is not always the best solution, actually. And these penalties, or this malus system, reflects a little bit, at least, that this situation. We could have chosen as well more statistic values by saying, oh, we take the, a value that is sort of worst case, but yeah, we have chosen this malus system based on data set categories. I'm happy to share this document, but are you able to read German banked? Maybe, but maybe you can read it. Then other questions. Audrey, same as above, but for demolition at end of life, we don't look at the demolition at the end of life, the demolition process at the end of life yet, but this is really due to there's data lag and the added value of having this information additionally to the impacts of the recycling process or the disposal processes. We don't see it currently. Dominika, what have you seen as a key component that makes LCA achievable in Germany that might be missing in other countries, which poses a barrier to start applying LCAs in those countries? Actually, it's the chicken and the chicken egg thing. Of course, it was a lot of work to convince sort of the building, manufacturers to provide data, EPDs or association data, or at least some data, consistent LCA data, and the release of this Ökobaudat version 1 and 2 and was really the kickstart, and that all of a sudden everybody, all the auditors started asking for EPDs or more specific information because they had to do the LCA calculation for DGNB. I think this was a sort of this push and pull situation, and then at the biggest boost, I would say, came when the European standard finally was released in 2012. Then all manufacturers were very confident in that the EPDs, for example, or the LCA calculations that they are doing are comparable. They can communicate it. So this was really quite important. Audrey, you asked something about, Dominika, I hope this answers your question. But as I said, for example, I thought that building LCA calculation tools would come much quicker. And I would love to see it much more widespread. But anyways, I think we're on a good path. Audrey, how do you account for changes in the energy mix? For example, if a coal-fired power station suddenly ramps up. Suddenly, we're not doing this. So actually, it's we're using data sets that are calculated for a year. And they are based on statistics from the industry, and the data sets, the sudden incidents are not really covered in LCA calculations. Yeah, Nicole, thank you, substitute. Audrey, you asked for the tools, the different tools. We allow more than the 5 tools. I'm sorry, this might be a misunderstanding. So there are 5 tools available. Maybe I've missed, no, actually, I think 5 tools available that are completely according to DGNB methodology. They are differing, yes, but only in the handling and prices sometimes. 2 are free, no, 3 are free, and 2 you need to pay. And then there's much more. So a lot of people calculate building LCA in Excel or with Access tools. Audrey, you ask, if smart buildings become more mainstream over the next 20-30 years, will you start incorporating technological elements into the calculation? Yes, we will. It is just for us a phase with a simplified calculation that it is allowed not to look at all the details of the building technology, but a clear message now is that we have this factor, increase the factor if you're not considering it, and we will constantly increase sort of we want to constantly increase the pressure to take a detailed look into the building technologies, because we also see already today that all the appliances, nice smart building appliances make a lot of the impacts. Alphonse, you ask again, you say you still haven't understood that why we haven't considered transport emissions between factory and the building. It is not difficult to calculate. I'm totally with you. We also have the data sets for the transportation, but honestly, it is quite a big effort, and it is not within the sphere of influence. So we really want to not over stress the effort that is already taken, and that people start playing around with the results instead of having the of course scientifically true picture of the building itself. So we have decided now currently still to leave it out, although it is important. Yes, I think the download presentation and the will be sent to you. Pat, how to assess the quality of the LCAs and the qualification of those carrying out the LCAs. We do have verifiers which look at each and every detail of the calculations. It is much easier if people use the tools that are already pre-checked. So in these cases we only need to check the input data with the real building data. In cases where people hand in Excel files with own calculations, we of course have to check all these tools. It's quite an effort, but it's worth doing it. And yeah, so the qualification, this is the result of the LCA, so we're really checking each and every detail. We also have an import module or an import tool into our own scheme, which in future allows to look at the results more automatically. The qualification of those carrying out the LCAs, it is part of the report that has to be handed in, that the qualification of the one who calculated the LCA has to be proven, or at least named, but we don't have the auditor is the one who stands for the results, and the auditor is goes through a verification through testing and a continuously development process at DGNB. Bengt, you read German, that's very good. I'll send it to you. Nicole, you ask a very important question. You have mentioned that you have gathered an extensive data set over the years. Have you published any average data for buildings from that data that might help us to understand the relative impacts in different modules? Until now, we only have published sort of the overall figures for the embodied impacts, which can be found actually in our criteria. I'm currently working on an internal research project to get the results out of our databases also on building elements level. But I'm not that far. Maybe we're a little bit understaffed currently, but it is very important for us. Yes, Nicole, as well. Pat is asking if the ESUCO database can be released for use in European countries and outside for use outside DGNB. Sure, it is a database that can be used. It is, I'll talk to Christine how the access to this database can be managed. Izuko database. So I'm really I thank you that you have the time. So there's some more questions. Could you please give us more info on the Izuko database? Yes, happy to do that. I'll ask Christine if and how we can give you an insight into the database or share it with you. Because it's currently it's available for DGNB auditors, but we'll see. Then the last one, sorry, I didn't want to repeat the question. It was okay, good. No worries. So this looks like these were all the questions. Is there anybody who wants to say something? Raise your arm or do I don't know. I don't know. I don't want to unmute all of you. If you don't have any questions yet, I'm happy that you have been with me and that you took your time. And that's it. Talk to you soon and thank you for your time. Thank you. Bye, bye, bye.